Oh yay, binary division, more death by PowerPoint to yeet your brain. This is of course section 9.4.2, the interrelationship between software and hardware in the software design and development syllabus. And for once I got the name of the syllabus topic right. So let's have a remember about long division, because this is going to look at how binary division works. Now, if we remember long division from primary school, or from early in high school, 45 divided by 12 equals 3.75. And when we do the sum, the calculation looks a little bit like this. Forgive my dreadful handwriting. First step is to work out how many times 12 goes into 45 and subtract that number. 12 goes into 45 3 times. And so therefore 12 times 3 is 36. We subtract 36 with a remainder of 9. Bring down the next number, which is after the decimal point, so it's a 0. And so we now have, how many times does 12 go into 90, which is 7. So we subtract 12 times 7 is 84, leaving 6 as the remainder. And finally, bring down the next 0, so 60. How many times does 12 go into 60? 5 with 0 remainder. And that's how we work out long division. Now, this presentation is not teaching you how to do this process. If you are unfamiliar with this nature of long division, please go and harass one of your maths teachers, and hopefully they can give you a quick refresher on this process. But this theory is being used to explain how binary division works, because this is how CPUs do division. So applying this into binary. Well, remember, CPUs only shift and add. The shift part is where we bring down our zeros, and the add part is where we add the 2's complement. Or add the negative, which is the 2's complement of the number. So when we do this now for us in our calculation, well, 45 divided by 12 is 3.75, like we said. Just so I know what my binary numbers are going to be, 45 is 101, 101. 12 is 1100, and 3.75, or 3 3/4, is 11.11. So I know what my answers are going to be. This is just to make sure I know what I'm trying to do. So here we have our binary division. 1110 dividing into 101, 101. To begin with though, 1100 as my divisor is also going to be my subtractor. So I need to make a 2's complement of that number. So the divisor is 1100. Its 1's complement is the invert of that, 0011. And its 2's complement is 0100, which is the 1's complement plus 1. Now this next step takes a few liberties, so I'm going to go slowly. The question we ask ourselves is, how many times does 1100 go into 1? 0 times. How many times does 1100 go into 10? 0 times. How many times does 1100 go into 101? 0 times. How many times does 1100 go into 1011? And I checked this a few times as I was making it. 0. How many times does 1100 go into 101101? Once. So we put a 1 in the tens column, which is actually the 2's column. The next column across is the 1's. And that'll be that's the 4's column. So that's the 1's column, which I haven't used yet. The 2's column, the 4's, 8's, 16's, and 32's. So I have a 1 in the 2's column, if you're dealing in decimal with the 10's column. And now we have to, we've got one lot of 12 in that number, so we have to subtract 12. We can't subtract 12. We have to add minus 12. So there's a 2's complement, 0100. And now we do some binary addition, because we're adding a negative number. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 10, carry the 1. 0 plus 0 plus that carried 1 is 1. And 1 plus nothing is 1. So my answer is now 11010. But because this is a subtraction, you drop the leading 1. Bring down the next value. So now how many times does 12 go into 10101? And the answer is 1, and this presentation was a bit too fast for me. So 1 in the 1's column, and again I subtract 12 by adding minus 12. which gives me an answer of 11001. Once again, delete the leading 1. So now I still have 1001. So now I'm getting into the fractional part of the calculation. So I've got no numbers to bring down here, but that's okay because I'm going to bring down, after the binary point, a 0. And once again, there's 1, so 10010. There is one lot of 1100 in that. 1. So again, I subtract 12. Subtract 1, add minus 12, 0100. To which my answer is 10110. Again, drop my leading 0. And I still have a remainder, so again I bring down my next 0. And we can see here 1100 is the same as 1100. So there is one lot of 1100 in 1100, one lot of 12 in 12. And so again I add minus 12. Pardon me. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 1 is 10. 0, carry the 1. 1 plus that carried 1 is 0. Carry the 1. And remove the leading 1. My remainder is 0. So therefore, yes, as I worked out, 101 divided by 1100 equals 11.11. Some steps in doing this. You add the 2's complement in your subtraction step. You drop the leading 1. In software design and development, especially when it comes to exams, the answers will always resolve. I would be doing what I did in the previous slide, which is put it all together as a, pardon me, put it all together in a number line so I know the numbers that I'm looking for. And more important than anything else, be very, very neat and methodical. Too often when I was preparing this slide, I'd have the working out on a piece of paper and I get it wrong and have to start again because I was not being very neat and methodical. Okay, here's a couple of calculations to complete. 49 divided by 14 equals 3.5, and 125 divided by 40 equals 3.125, which is 3 1/8. Create your number line to ensure you know what values you're looking at. Show your 2's complement conversion, add the negative, drop the leading 1, and be very neat. Now, I'm going to forward the slide once more to show you what I mean by being very neat. So I created my number lines. Here are my number lines of all my different values. And you'll notice that I haven't put anything in the slides that are blank. So I've got a binary point down between the 1 and the half. For most of my numbers, I haven't had to worry about the binary point, so I've left it there. But where I have 3.5 or 1.1, I've put it in. So these are the numbers I'm dividing and the answer. 125 divided by 40 and the answer 11.001. What I want to point out here is this first one, 49 divided by 14. 8 plus 4 is 10 plus 2 is 14. That's okay. But what I've done here is my 2's complement conversion. So I started with the correct number, 1110. The correct 1's complement, 0001. The correct 2's complement, 0010. But when I've done my first subtraction, I've made a mistake and I've transposed values. And it got me all this way through, got me all the way through this part of the presentation, or this part of the calculation, before I realised I'd made my mistake. Hence the reason I'm saying be very, very neat and very, very methodical. Now, this is the questions. There's your hints. I would say pause the presentation, pardon me, and do your calculations. In a few seconds' time, I'm going to forward to my answers and see if you came up with the same responses. And if you did, congratulations. And if you didn't, work out where you made your errors and see if you can get the right responses. So once again, there's my number lines. Pause the video because here come the answers. If you got those answers, congratulations. It's the working out that's important. So I hope you got these answers. If you did, give yourself a hearty slap on the back. And that's the end of the presentation for the time being. Well done.